10 ohms. Let's say that our battery source is 120 volts. And I want you to find the current in the circuit using Ohm's law. So this is a really simple application of Ohm's law. And then I'm going to start teaching series circuits, which I intended to start doing like, I don't know, 20 minutes ago. Okay. So you can set this up in any format that you choose, R equals V over I. If you want to rearrange it, you can do so. Some people prefer V equals IR. So I'll use this format. So we have 120 volts is equal to an unknown current times 10 ohms. So as you can see, the current in this circuit is 12 amperes. So this is just a simple circuit. And again, to reinforce what I said before, if we wanted to measure that current, we would add an ammeter into this circuit at any point, but it should just be along the same path as the current is flowing in. So this is going to measure that 12 amperes of current that we just calculated. And if I want to measure the voltage, I can put a voltmeter across our voltage source with one lead attached to the high voltage end and the other lead attached to the low voltage end. And this is going to measure our voltage. There's actually one other place that I can attach this voltmeter, and I think I want to tell it to you now because I think it's going to help you understand series circuits a little bit better. So actually, if I wanted to measure this 120 volt electric potential, I can move this voltmeter up to over across this resistor. So what you'll realize, hopefully, when you look at this, is that just like across this battery source, we have a high voltage end, which is 120 volts, and a low voltage end, which is 0 volts, which is pushing that current down that gradient. We have the same thing happening across this resistor. So this first end, when the current first encounters the resistor, this end right over here is going to be our 120 volt end. And then once the current steps down that resistor, since it is the only resistor, it will have stepped down to 0 volts, approximately. Okay, so resistors also have a high voltage and a low voltage end. And you can kind of think of it as a staircase. Let's say you climbed up, or the charge climbed up 120 steps. It's going to need to climb back down 120 steps. Okay, so that's the best analogy I can give you for this. So we will actually always have a voltage drop across each resistor. So there will be a voltage drop across each resistor. Okay. So I want to move forward. We're going to start talking about series circuits versus parallel.